Hi everyone, welcome to our channel. Today we are going to solve the minimum add to make parenthesis valid problem. Also, we will be comparing the code for longest valid parenthesis problem with the present problem. So let us see this. The problem says that we have to find minimum parenthesis whether it's a opening or closing so that the given string becomes valid. And if we see this problem, there are only opening and closing parentheses of one type. So one more thing we can see that where we can add. So we can add in the front because in this problem we can add the parentheses in the front and we can also add at the end. So there are two ways we can add the parentheses to the following string so that it can become valid. So first we need minimum add. Second, we can add it at the left and the right. What we have to add? So that's the third point. We can add opening or closing parenthesis. So this is the understanding that we can get from this problem. In the next step, let us see some more examples of this problem. So these are some of the examples of the present problem. Now, the red ones are basically the minimum that we have to add so that the string becomes valid. Now in the first example, we can see that there is one opening bracket we have to add so that the string can become valid. And in the second example, there are three brackets that needs to be added. Red refers to the ones which we have to add. Now, in the example 3, there are two brackets which we need to make this valid, and there are these two brackets which we need to make these two valid. Now in the example 4, although they are equal number of opening and closing brackets, still they are invalid. So we need 4 more. That is here 2 and here 2. So 2 in starting and 2 in ending, and 2 in starting are opening, 2 in ending are closing. So that we need to balance this string. That's why the output is 4. In this the output was 4 because there are again 4 brackets that were needed. In this the output was 3 because we need 3. In this the output was 1 because we need 1. So these are some of the examples. Now one thing is for sure that we have to count the number of invalid opening and closing. That means how many closing are there for which the corresponding opening brackets are not there. How many opening are there for which the corresponding closing is not there. That can help us in finding minimum add. So in the next step, let us write down these inferences and think about the algorithm. So let us see this in next step. So these are some of the inferences. First, we have to track one type of bracket to get how much we have to add. That means that let's take opening as one type of bracket. And if opening is more than closing, then it's invalid case. Second, if closing is more than opening, then that's also invalid case. How we can get that? So if opening becomes less than closing, then that can be invalid. So this invalid case we have to count, and the same will be the number of minimum add. So that's how we can get our answer. Now, only two position we can add, opening and closing. That is for our understanding. But the only output that we have to return is the count. So can we design our algorithm based on this inferences? Let us see that in next step. So this is the algorithm that we will be following, and in this algorithm we will be iterating from left to right on a string. So in this loop there will be 3 steps, and in the first step we will be incrementing the counter if it's an open bracket, and if any closing bracket we will be decrement the counter. Now what is this counter? This counter is basically this opening b variable, and if the counter is equal to -1, then there will be two things happening. We'll be incrementing the result, and we'll also increment the counter. That is to make it valid so that in future if there is any invalid, that we can capture it again. If it goes negative, that's an invalid case. Now at last when we come out of the loop, there will be result plus counter, that is res plus opening b. So now why do we need these conditions? So if we see this counter equal to -1, so whenever there is a opening bracket more than closing. So in both of the cases, both same variable is incrementing and decrementing. And let's say if the closing are more, so it will go to negative, and that we have to capture in result variable. That's why we are incrementing result. And now again we are incrementing the counter because in future, let's say if closing is again less, so that will so before that if there was again closing bracket, so we have made the counter as -1. Now we have incremented it to 0. Now we got the again closing bracket. Again it will go to -1 and that will be captured. So to come inside this loop for an invalid case, we have to make this counter +1 so that it becomes again valid. Now what if there are more number of opening brackets? So that's why we need result plus counter. So whenever there are more number of opening brackets and we reach to the end of the string, so that many will also be added, and that many closing brackets we need, so that will also be included in result. Let's try run this with one of the input given. So there is opening bracket, so we have to increment our opening b. Now there is a closing bracket, we will decrement our opening b. Now there is again closing, so this becomes -1, which is this condition got satisfied. So now we have to increment the result. So initially both of them will be 0, so 1, and then increment the counter. Now make it as 0. So these two will be happening in single iteration, and in the next iteration again you will see there is a again closing bracket. So again it will go -1. We will increment our result, and again it's this will be made as 0 so that in future if there are invalid cases, we can capture them. Now in the next iteration there is the opening bracket. Let's capture it. So it's opening. Now there is again opening, so definitely we will increment this 2. So now I think we have reached to the end of the string. So now whatever the result that we got as 2 will be added in result. So the answer comes as 4. And if we see in our input, we needed 2 opening brackets and we needed 2 closing bracket to make it valid, so that this and this can be made as valid. So that's why the answer is 4. So we can see that yes, we got 4 as the correct answer by following the given steps. Now in the next step, let us see the Java code for this. Following is the Java code for minimum to make parenthesis valid. And here we can see that we have two variables declared. So res is for counting all the invalid brackets, and opening b, it's a counter that will be incremented and decremented whenever there is an opening and a closing brackets respectively. Now we can see that we are iterating a full string from starting to last, that is from left to right. And then whenever there is a opening bracket, we increment opening bracket b plus plus, and then opening b minus minus whenever there is a closing bracket. So in else part there is only one case, that is the closing bracket, and whenever it's equal to -1, that is closing is more than opening, then we'll be capturing the invalid and making it to 0 so that we can capture future invalid. And then at last there can be some opening that may be more than closing, so that's why we are adding it into the rest, because they are also invalid and needs a closing, corresponding closing. So this is Java code for it, and let's go to next step. If we see the time complexity of the present problem, we can see that we are iterating from I equal to 0 till the last character of the string. So that's why it's big O of n, where n represents the length of the string. Now, coming to space complexity, we have only two variables. That's why it's big O of 1. So let us see and compare it with longest valid parenthesis problem and see what similarities are there in the present problem and that problem. So as you can see here, first similarity is that in A we are iterating from 0 till the last character of the string. In our problem also we iterated full length of the string, and then there is a opening bracket, we do some logic, and then again here also there is a similar logic which we do when there is an opening bracket. Now what if there is a closing? That's the other part. Then we do little different logic, but it's kind of similar. Now there is one more if condition, if closing is greater than opening. So here opening is equal to -1. So this is also similar. Why? Because we are decrementing same whenever there is a closing bracket, because in else case there is only closing bracket that is left. So if closing is greater than opening, that's similar to opening equal to -1. So we capture it in the result and make it again as valid. Here you can see opening and closing. Again, they are made as valid. So that's why there are four similarities that we can find in these two. That's why there's just one concept needed to understand and little manipulation of the code in both of them, and both of the problems and most of the parenthesis problem can be solved. So if you liked our explanation, do hit like and subscribe our channel. Till the next video, thank you.